Hi, I'm an old guy and I do maths. Today we're looking at polar coordinates, another way to locate a point in space. Now, in order to understand what goes on here, you need to have a very basic knowledge of trigonometry and an understanding of Pythagoras. There's not much more to this than that, really. And what we are talking about is a way of locating a point in space. Now, this is in two dimensions. We've got an x axis and a y axis, and we have a point here, 3, 4. And what I've gone to the bother of doing is running a line from here to the origin. Now, it should be readily apparent to you that if this point is 3, 4, so 3 along the x-axis and 4 up the y-axis, that this length here will be 5. So basically what it would create is a 3, 4, 5 triangle, right angle triangle. And 3 squared plus 4 squared equals 5 squared. The line linking this point with the origin is 5 units. Now, how can we describe that in another way? Well, we can use polar coordinates. Now, polar coordinates consist of two things. They consist of an angle, which we will call theta, and a line r, a radius, as if this were the radius of a circle. And so if we take what we have here and translate it to this, to polar coordinates, what we have is our angle theta there. That is the angle that a resultant vector, if you want to call it that, or a line from the origin to the point, the angle that line makes with the x-axis. And the value r is this distance here, which we can calculate using Pythagoras. We can then use trigonometry to calculate this value. So, what do we know? Well, we know that this is 4 and this is 3. And so we can use any of the various trigonometric ratios to calculate this angle. So, let's go to work. What we're interested in is this and this. Now, we know this, we've got to find this. So, let's say that our angle theta, let's go for a sine. The sine of theta is equal to the opposite over the hypotenuse. In this case, 4 over 5. And from that, we can get our angle. So, let's just get the calculator out and find out what that is. And there we have it, 53.13 degrees. So our polar coordinate for this is 53.135. And just to make sure that this this point is well understood, I'll just draw in a very rough Cartesian plane here, y and x, and what we're looking at is we're looking at this as a point somewhere here in this quadrant. Maybe in a later video we'll get into how you locate things in other quadrants. It's not particularly difficult, but it does need a fairly good knowledge of trigonometry, and circular trigonometry would help. Okay, so what we have is we have an angle 53.13 degrees, and we have a distance of 5, which would put our point there, which we could safely translate back into the more familiar form as a 0.34. How could we be so sure of that? Well, we know that that is 5. We know that this angle is 53.13, so we can find that length, which is simply the sine of, it's something that we can derive from the sine of this angle. Anyway, that is a very brief rundown on polar coordinates and how they work, and I hope you found that useful. If you did, please like and subscribe. There'll be some elaboration on this in further videos. Thanks very much for watching. Bye.